Welcome to introducing the world's first self-healing test execution cloud with Adam Carmi. Adam is the co-founder and chief technology officer for Applitools. He's the inventor of visual testing and has more than 20 years of technological leadership and innovation experience. Prior to founding Applitools, Adam held management, research, and development positions at SafeEnd, IBM, Microsoft, and Intel. He holds a BSc and MSc degrees in computer science from the Technion and regularly talks about software testing at conferences around the world.
Hi everyone, and welcome to this introduction to the Applitools Execution Cloud, the world's first self-healing test infrastructure for open source test frameworks. The Applitools Execution Cloud allows you to execute your open source based tests at infinite scale on the Applitools infrastructure. It is lightning fast, built for speed with a modern architecture, and it actually runs faster than any of the competing device and browser apps. It is affordable. It costs half the list price of the competition, which means that if you change your test to run on our infrastructure, you can actually save a lot of money on test infrastructure. Using the execution cloud, you can execute all of your tests, whether they're using eyes for visual validation or not. You can test public-facing applications as well as local applications behind the firewall. And by adding the execution cloud to our portfolio, Applitools can now provide an end-to-end platform that allows you to both author your functional and visual tests and execute them all on a single platform offered by Applitools. But the most exciting thing about the execution cloud is that it allows you to get self-healing functionality for your open source based tests. It means that you can drastically increase the stability of your tests and builds and save hours in reviewing failed test reports and fixing broken tests. And in order to do that, you just need to take your existing tests and run them on the execution cloud without having to change even a single line of test code. So I'm super excited about this new offering. And if there are any guys from Applitools here today, then kudos for building such an awesome product. We have a lot to cover. We'll start by explaining the benefits of running your tests on cloud infrastructure. We'll then show you how you can run your functional testing at scale on the execution cloud. We'll explain how you can run effective cross-on-device browser testing on the execution cloud. And last but not least, we'll talk about self-healing, what it is, how it works under the hood, and in which scenarios it can help you a lot. Of course, we'll do a lot of demos along the way, and there will be time to answer any question that you may have at the end. Okay, so let's start with the basics. Why do we need to execute tests faster? So if we look at the best-in-class teams, we see that they actually make sure that they build end very fast, anywhere between 5 to 15 minutes. This time is fast enough for the developers to wait for the test results before they move on to their next tasks. In terms of frequency, they aim to run the tests on every update to a pull request, taking into account that each developer on the team can make multiple updates every day. And in terms of coverage, they try to maximize it and include both coverage for interaction logic, for example, making sure that a button can be clicked and that it does what it's supposed to do, validating business logic by asserting on the application output, and doing cross-on-device browser testing as well to make sure that the UI renders correctly across different devices and browsers and operating systems. By doing all of this, they make sure the developers get the feedback on the code changes that they just pushed immediately before moving on to their next tasks. And by doing that, they save a lot of time context switching from their next task back to the previous task to handle the bugs, and then back to the next task that they were working on. And with all that time that is being saved, they can actually increase the velocity of the team and make sure that more features are delivered to customers and help the business succeed. The reason to run all these tests in the cloud is that modern applications require hundreds of tests to cover properly. And if you need to run so many tests in a short period of time, like 5 to 15 minutes for a build, you need to have multiple builds running in parallel. You need to have a very reliable and scalable infrastructure in place. And building something like that is extremely difficult, and it's even more difficult to maintain it. First of all, you need to build infrastructure that is extremely scalable. It has to be elastic in its ability to scale, so to keep the hosting costs down. You constantly need to deal with updating the operating system, constantly upgrading devices and browsers because new versions constantly come out. You have to do all this maintenance while retaining high availability, because if you turn off the system, it will break builds for teams and they will be unhappy. Because your tests are running on remote browsers, you'll have to spend time developing debugging features such as collecting logs and video recordings of the executions on the remote browsers. You need to invest in dashboarding and reporting so people can understand where their tests are running, when will they finish, are they queued, etc. And of course, if you build it by yourself, you miss out on great premium features that are offered by the lab providers, such as Selffilling and other features. So at the end of the day, if you try to build it your own, it ends up costing more by paying salaries to very experienced people while getting probably an inferior product to work with. So let's talk about fast functional testing. The goal here is to give fast feedback to developers on code changes. You want to make sure that the interaction logic works. You want to make sure that the business logic works by validating the application output. And if we look at the best-in-class teams, what they do is that basically they choose a single browser, in most cases Chrome, and they just run the test only on that browser. Why on just one browser? Because first of all, it helps keep the number of test runs to a minimum. Less test means faster execution, less concurrency, and therefore less cost. It also reduces the amount of test results that you need to analyze and avoid having every bug in the client or the server failing many test executions across the different multiple devices and browsers that you're running on. And in terms of coverage, by running on a single browser, there's a negligible loss of coverage because it is extremely unlikely that if you click a button and it works on one browser, it will not work on another. And it's extremely unlikely that the application output will be computed correctly on one browser but not on the other. Of course, all of this is correct unless the UI is distorted or malformed on a specific device or browser, but this is a different use case that we'll cover later. So let's see how we can actually run just a fast functional test on the Execution Cloud. What you can see here is a JavaScript Selenium test on Loca. And the test is very simple. Basically, what it does, find that tab, we will be working with this demo application. There is a login form here. The test will basically perform a login, just put in some username and password, and then click the sign in button. We will click the first locate the sign in button based on its login ID, and then click it. Once we click it, we get to this second page here. And just to make sure that we reach the correct page, we will search for this element over here that has an ID that is called time and make sure that the text is as we expect it to be. Okay, so a very straightforward functional test. Here you can see the implementation of the test. Start out by just navigating to the demo application. We then perform the login, identifying the login, the username, password, text boxes, and sending and just typing the username and password, and then clicking the login button. Then we get to the second page. We find the closing time title and make sure that it has the correct text. So very straightforward test. It has nothing to do with eyes or any of the Applitools SDKs or anything like that. A very straightforward test that you can run locally. Now, before each test, we need to set up our Selenium driver. And this is done by the getDriver method. If we look at that method, instead of starting a local browser, we are just building a normal remote web driver that works on the Applitools Cloud, Execution Cloud, and using the Execution Cloud specific capabilities. Okay, so there is nothing fancy going on. If you have Selenium tests that work with a remote web driver, you can just change the driver to work with Applitools, the Execution Cloud, and it will just run there. In addition to getting the driver, we are also executing a script that is called Applitools Start Test, where you can basically provide the name of the application and the name of the test that is executing. This is useful to show the correct test name in the dashboard that shows you a report of all the executed tests. At the end of each test, we get the test status and we report it through the driver by executing an end test script with the test result. And this will allow us to mark on the Applitools dashboard whether the test passed or failed. So pretty straightforward. Let's run this test and see what we get. You can see us getting the driver for the Execution Cloud, going to the demo app, performing the login, and doing the assertion. As you can see, the test was pretty fast. It took 2.5 seconds, and overall, the setup and teardown of the entire fixture was just 8 seconds. Let's try and just generate a failure. Let's say that the expected text should be your nearest branch 2, and rerun it. Again, doing exactly the same things. And now we have our failure where your nearest branch 2 is not what we get on that message as we expect. So if we head back to our dashboard, to the Applitools dashboard and refresh, we can see that we have our 2 latest runs. We have a run here of the Execution Cloud demo runs with Applitools test that has passed. And we have the second run that has failed because of the status update that we just did in the after each. We can also control the status that is reported here. Now, besides having the fact that the test just ran, we can also see a lot of information to debug and understand what happened on the test. So for example, we can easily see a log of all the interactions that went on in the test. For example, we can see that we search for the login button in order to click it, and everything else basically that happened during the test. We can also easily get a recording of a video recording of the run that allows us to easily see what happened on the remote machine. So just in case that something didn't work, we can understand what happened as we cannot run it locally, right? Just to debug it. So the usual stuff that you would usually expect to have when running tests remotely. Now, I mentioned speed before. You see the performance of these runs, very fast test execution, and very fast test completion, times 8 seconds. Let's compare this with another leading lab provider. Okay, so I won't disclose any other names. The test is exactly the same. Okay, you can see that we are going to the same application, doing exactly the same step, exactly the same validation. The only difference is that we are getting a different driver, which is hidden here in this method. Let's run this test and just to get an understanding of the performance. Now getting a driver for another lab provider. So you can see that the test itself took almost 6 seconds compared to 2.5 on the Applitools Execution Cloud. and the overall setup and teardown took 13 seconds instead of 8. So getting to twice as fast test execution is something that is very normal for the execution cloud, and this means a lot when speed matters. So what we did now is that we tested a public-facing application. In many cases, you want to test local applications behind a firewall or a staging environment. This is something that is super easy to do with the execution cloud. All you need to do is just set up an environment variable where your test is executing, Applitools tunnel is set to true, or provide a browser capability, Applitools tunnel to true. And this is all you need to do for a tunnel to be automatically spawned when you are executing your test, which will basically allow us to test the application under test behind your firewall. And as soon as the test complete, this tunnel is destroyed. Okay, so super easy to test applications behind the firewall. The next use case I want to talk about is how to perform effective cross-device and browser testing and run them fast. The goal here is to verify that the UI renders the application output correctly across different devices, browsers, window sizes, operating systems, and form factors. The reason we need to test across all these devices and browsers is that different browsers are based on different layout engines that would actually render a slightly different UI given the same DOM and CSS. Because of that, we cannot assume that if the UI renders correctly on a certain browser, it will work on another, or if it works on a certain form factor, it will work on another. Another reason for testing this stuff is that developers develop the app on a single dev machine, which means that when they're testing as part of the development process, they're limited to one browser and one OS. But also, if you have a responsive web application that changes its layout according to the form factor or screen size of the device that it runs on, all these responsive rules are very prone to error, and it is very easy in just about any application out there to find a bug that is related to these responsive design rules. As a matter of fact, you can't use the traditional assertion-based approach to do this type of testing effectively. You need to validate this type of tests visually. The reason is that in each of your pages that you need to validate, there are hundreds of UI elements, and each one of them has dozens of properties. If you're testing on different devices and browsers, these properties will have different values that are specific to each form factor, device, and browser. So we're talking about thousands and thousands of assertion line of code for each page, which you would never write and will never be able to maintain. The best way to do this is by using Applitools Eyes and the Ultrafast grid, which is, of course, an Applitools product. Eyes provides you with the ability to do function and visual testing powered by the visual AI technology, which is basically a large collection of computer vision algorithms that mimic the human vision with very high accuracy. And basically, it allows you to drastically increase your coverage while substantially reducing the amount of test code you need to write and with a fraction of the maintenance effort required with a traditional approach. The Ultrafast grid allows you to execute your visual AI-based tests across different devices and browsers in orders of magnitude faster than you can with any other test infrastructure. And I'll spend a few minutes to explain how all this works and how it works with the execution cloud, and I'll show it to you in action. So the way that you use Eyes is that we provide you with an SDK that you can use to add visual checkpoints to your existing tests. We support over 50 different SDKs that cover all the UI technologies, programming languages, and test automation frameworks. So whatever it is that you're using, there's an SDK for you that you can use to add visual checkpoints. When this visual checkpoint executes, what it does is that it captures a full-page screenshot of the application under test at the current state of the test and compares it with the baseline image. If there are no differences, the test will pass. If there are differences, this line of code will fail just like any other assertion. and the description of the failure will contain the URL of the test results in our dashboard, where you can clearly see the baseline image on the left-hand side, the checkpoint image on the right-hand side, and the differences are clearly highlighted in pink. In this case, we can see that the forgot password link has disappeared. Now, maintaining the automated test becomes super easy. You don't need to go back to the code and fix it. All you need to do is decide whether to accept or reject this change. If the change is valid, it is just a new feature, and we intentionally remove the forget password link. All we need to do is click an accept button, and the checkpoint image will be saved as a baseline image for subsequent test runs. If, on the other hand, this is an unintentional bug, we just reject the new screenshot and report the bug directly from within the app. We have collaboration tools that allow us to interact with team members and discussing this issue. We can easily send it to Jira with all the relevant information, but the workflow is very, very simple and straightforward. Visual checkpoints or assertions have many advantages. First of all, they allow you to enhance your existing tests. You don't need to write them from scratch. And replace your traditional assertion with those visual assertions. By doing so, you can reduce the amount of test code that you write by up to 80%. This means 80% less code to write when you're authoring a new test, but also 80% less code to maintain for the entire lifetime of the test, which is huge. Each of these visual checkpoints gives you complete visual and functional coverage for the page and is equivalent to writing hundreds, if not thousands, of traditional lines of assertion code. Okay, and it works, the same line of code works across all the different devices and browsers that you're running on. This type of testing actually allows you to catch any unexpected defect, any change that will be visible for your customers, something that you can achieve today only with manual exploratory testing. And most importantly, it does not break when the UI changes. There is nothing in this line of code that depends on the implementation of the page, which means that you no longer need any developer time to spend on maintaining validation logic. The fact that everyone on the team can go to the dashboard, understand the test results without having to read log files, and accept and reject changes means that now everyone on the team can participate with maintaining automated test results, and this frees up the time of the developers to either develop the product or continue and add more tests and keep up with the changes in the application. Okay, so teams using eyes really are able to scale their test automation and escape this glass ceiling where they just spend most of their time maintaining broken tests and fixing broken tests and just don't have time to add more coverage. Another advantage of visual checkpoints and using visual AI is that it allows you to use the Ultrafast grid to test, to execute and get coverage for any device and browser that you want to test on by only running your test once on a single device or browser. And here's how that works. When the SDK executes that visual checkpoint, instead of grabbing the screenshot, the full page screenshot from the browser where the test is running, what actually happens is the SDK grabs the entire view hierarchy from the browser. That means the DOM snapshot, CSS, fonts, images, all of that. It then takes all this information along with the list of devices and browsers and uploads them to the Ultrafast grid, which then within seconds spins up those devices and browsers, serves them with the same resources that were available on the browser where the test is running. And in return, they produce exactly the same UI that you would have gotten in this state of the application as if you are running the test there, although you are not running the test on these devices and browsers. After all these devices and browsers have rendered the UI, the Ultrafast grid takes screenshots of all of them and uses eyes to check all of them at once. Okay, so the end result is that you're running a test once, and at the same speed and stability of running a single test, you're getting coverage on any combination of device, browser, and operating system that you want to get. Okay, it is super fast. It can get to be 50 times faster than running your test multiple times on multiple devices and browser. It is super stable, and it is super simple to set up, because all you need to do is just provide the list of devices and browsers you want to test on. You don't need to make any changes to your test infrastructure. The SDK handles everything for you. Okay. So the way the eyes and the Ultrafast grid work together with the execution cloud is that you can take any test that you have with eyes, execute it on a Chrome browser on the execution cloud, and from this single run, every checkpoint, every visual checkpoint that takes place is then multiplied and rendered across different devices and browsers and produce multiple test results for you in the eyes dashboard. Okay, so a single run on the execution cloud produces all that coverage across different devices and browsers. So let's see that in action. Basically, we run a very similar test with a small change. We go to the same demo application. We do exactly the same login step, but instead of asserting on the text of the title, we will actually do a visual checkpoint. Eyes check. Okay, if you think of it, if we would have kept the original assertion, what coverage would it provide us across different devices and browsers? Is there any chance that the text would be different on a different browser? Probably not, right? The eyes checks give us the true coverage that covers everything that happens on the UI on each of the target devices and browsers that we want to test on. So all we do is this eyes check to replace the assertion that we had before. Now, before each test, we need to do a little bit more work. Besides initializing the driver that will run on the execution cloud, we are also initializing the eyes SDK, and we configure it to run the test and validate it on 15 different devices and browsers and screen sizes. Okay? Just a configuration that goes into the SDK. No need to do anything else in your test infrastructure. Similarly, before running the test, we are starting the eyes test, and after ending the test, we are also ending the eyes test, getting the results and printing them to the standard output. Okay, so very few changes that we need to do at the infrastructure level. We don't need to update each and every one of our tests, and we get the Ultrafast grid and eyes working together. It's also important to highlight that if you're using the eyes SDK, you no longer need to do to indicate the test name and the test status before and after each test. The SDK now takes care of it by itself. Okay, so you don't need to do the duplicate work. However, you don't have to use the SDK and do a visual AI-based tests to run on the execution cloud. As you saw in the previous demonstration, you can actually run a plain Selenium test that has nothing to do with eyes and run it on the execution cloud as well. So let's run this test and see what we get. You can see the test starting, getting a driver on the execution cloud, performing login, getting to the second page, and now running the visual checkpoint. You can see that naturally it takes a bit longer. We are not validating a single element. We are validating the entire page on 15 different devices and browsers, but still things are going very fast. The browser just collected all the SDK collected all the data, uploaded to the grid along with the list of 15 devices and browsers. They were spun up and rendered and checked, and everything is done 33 seconds from setup to teardown, very fast. You can see that we found a difference, detected differences. If we head back to our dashboard, you can see that although we had just a single run on the execution cloud, we actually have 15 test results, because that single run actually was duplicated across 15 different devices and browsers. We can see that some of the checks passed, but some of them are unresolved, meaning that we found defects. If we switch to the gallery view, we can see that we actually found defects on the mobile form factors. Okay, we can zoom in on that and see that on the baseline, we were supposed to have just credit available element, but now there was a bug in our application that only showed on mobile form factors where there was another element here that was supposed to disappear and it's still here. Now it's difficult to say what's going on and why that happened, but with root cause analysis, which is an eyes feature, we can actually click the diff and find out what changed, okay? What were the changes in the code? So we can see that there's an element here that is called the balance, and we can see that it was supposed to have size 0, but now it has a size. We can see that it was supposed to have display none, but now it's display block. And the reason for that is that it used to have a class on it, hidden mobile, but now it's mobile bug. So this is the change that caused this. And now as developers, we know exactly what happened and how to fix the bug, or at least we have a clue of where to start, a thread that we can start pulling to figure out what went wrong. Okay, so with eyes and the Ultrafast grid, we can actually get all that cross-device and browser coverage effectively without writing a lot of code, actually writing 80% less code. And with the execution cloud, we can execute that single run on one of the environments, any of them, to get just somewhere to run our test at scale. Okay, so this is how all these products work together. And this brings us to the third and final topic, which is self-healing locators. So as you know, each step in our test interacts with some UI element, right? We locate elements in order to either interact with them, clicking them or providing input, or to get their properties and assert on these properties. The way that we locate and find the elements that we want to interact with is with element locators, such as the one that you can see here. The ID, we are looking for a link that is a child of an element that has the ID navigation right. The problem is that the UI tends to change a lot, and either because front-end developers like to refactor their code, or just because there are product changes and constantly you add and enrich the UI or make it more simple. The problem is that if a developer would somehow change the UI, for example, he would place the link out not under the navigation right element, or change the ID from navigation right to navigation right 2 or any other name, or just remove the element navigation right, we will not be able to locate the element and our test will fail. Now, these failures always happen at the worst time. We're just about to have a release and all of a sudden many of our tests fail. Or I just pushed some code, I want to make sure that it works, and all of a sudden I have many failed tests and I need to stop what I'm doing. Everyone needs to stop what they're doing and start looking at the test results and figure out what went wrong and fixing the tests and then rerunning them. Hopefully they will pass this time, and it takes a lot of time, and it's like the worst time that you want to deal with that stuff. And this is the primary cause for delaying automated test feedback, and the primary cause for the high test maintenance overhead that we all are familiar with when we are basically doing test automation. Selffilling resolves this issue by finding the element even if its locator is now broken. And the huge value of that is that our test can continue running even after a UI change that broke the locators. And we can then, at a later time, when it's convenient to us, go back and fix the code, again, at a later time, or maybe never, because if we still find the element, why do we care? Why should we even change the code and bother with it? So how does this thing work? Basically, every time you run tests on the Applitools Execution Cloud and you're searching for an element, if we find that element, we capture hundreds of data points about it, including all its attributes, the location in the view hierarchy, details about its sibling elements and neighbor elements and its ancestors. And we take all that data and we store it in a database under the key, which is the locator that you use to find the element. And we do all of this every time you find an element. So the element can change in many ways and you can still locate it. Every time you locate it, we save the up-to-date information about it. Now, if the time comes and the UI changed and you're now trying to find that element and it doesn't work, we cannot find the element using the locator, instead of failing the request which would cause your test to fail with the no such element exception, I'm sure you're familiar with it, instead of returning the error, we try something else. We take the locator, we go to the database, and we try to retrieve the information that is stored there. If we have information, we then use our own proprietary machine learning algorithms to find the element for you based on all the information that we have. If we are successful in finding it, we relearn everything about it and store it in the database under the same locator. We indicate in our dashboard that there was a self-filling event, and we actually suggest a new locator that you can use to update your test code, although you don't have to do it. If all that happened and we found the element, we return it to your test, and so your test continues as if nothing happened. It just continues as usual, although the locator is no longer relevant to the current implementation of the page. The self-filling algorithms are actually incredibly robust. We can find an element even if simultaneously its properties change, its text changes, the position in the DOM changes, the size, location, color, all of these things can change. The goal is that if you as a developer, as a human being, is able to find the element on the page, following the fact that a locator is broken, we can do it as well. Okay, if it's similar enough that you can find it, we can find it as well. The algorithms themselves are adaptive in the sense that we keep learning on every run. We learn more about the element, which means that we can sustain and postpone the point in which the test fails indefinitely. Of course, if you completely remove the element or change it in a way that it has no resemblance to how it looked before, we won't find it. But this is acceptable and an acceptable result. But in any other case where you would be able to find it, we would as well. So there is really no point in updating your test code. And also, we implicitly wait for elements. Okay, so it also helps in stabilizing your test, and you don't need to do anything about it. Just run on our infrastructure, and your test will be more stable, and they will also self-heal. When is this useful? So naturally, it helps avoid test failures and the related test maintenance overhead following a UI change. And naturally, if you have UI pages that frequently change, then this becomes more useful. It also helps compensate for team members that have poor locator authoring skills. If you have people that are less experienced in finding strong locators, they might use locators that are not stable enough or robust enough, and this means that they would fail more frequently. With self-filling, this problem goes away because it's enough for the locator to work once, and once the element has been located, self-filling kicks in and it can find your element from that moment on, and the test will not fail. It's also very helpful in situations where the application has weak locators. It's often the case when developers develop their application without just thinking about the stability, and then they don't have strong identifiers to use for automation. And then as automation developers, you're stuck with elements that are difficult to locate. So it's super helpful there. You can just choose any locator, and from that moment, the test will be robust. And it's also very useful for testing applications with dynamically generated UI or dynamic IDs. If any of you ever tried to automate a Salesforce test with Selenium, you know how impossible of a task that is. But with Selfhealing Locator, it's very doable. So I'm sure that most of you are not hearing about self-healing for the first time, right? There are vendors and platforms that are already suggesting this technology for a few years now. It's not a new invention. However, the problem with this technology until today was that it was limited to proprietary closed platforms. The vendors would use this technology to lure you into their platforms, and if you would like to enjoy the benefits, the many benefits of this technology, you would have to make the tough decision of abandoning the test suite that you had and starting to write everything from scratch on the vendor platform, on the closed platform. Now, not only does this take a lot of work, it also, you lose the ability to choose the preferred test framework that you want to work with. You need to work with a language or APIs that the vendor allows you to work with. But it also creates a strong vendor locking because now you're tied to that platform, and if at some point you want to move away from it, you have to again make the tough choice of abandoning everything that you've done and starting from scratch all over again. I think that the wonderful news about the Selfhealing Execution Cloud is that now you can use it to self-heal your existing tests, your open source based tests, and you can do it without changing a line of code and doing any effort actually. You can still use your preferred test framework, and there is no vendor lock-in. If you decide at some point that you want to move away from the execution cloud, go ahead, it's your test, it's your code, and it will just run just as well locally or with another lab provider. So let's see self-healing locators in action. What we'll do is that we'll go back to our existing test, okay, our initial test, sorry, and we'll do a small trick. We'll go through the login flow, but before we click the sign in button, we will actually change its ID to be a different ID. We'll just inject some JavaScript to do it, and we'll also change the text here just to make sure that the new ID is working. And then when we try to click the sign in button with the old ID, with the original ID, it will fail, right? Unless we have self-healing in place that will just heal our test and allow it to proceed. So we are back to the same basic test that we had at the beginning, exactly the same test, only with the addition of these lines. Before we go through the login sequence, we find the button with the login ID and we change its ID to be blah blah ID. We then find the button with the blah blah ID and change its text to be blah blah, right? So if the ID didn't change, this line would fail. Right? Very simple. The rest of it is the same with the assertion at the end. What we are doing here, we're also enabling safe healing, just to show that the thing would really fail if self-healing is not enabled. Let's change this to false and run the test. So we're running it, getting the driver for the execution cloud, modifying the button, trying to perform login, and as expected, we got a no such element error. We're trying to find a button with a login ID and it doesn't exist, right? This is what we would expect to have. Let's turn on self-healing. I'm doing this in the capabilities of the driver. Okay, very simple, very trivial, and I run it again. And now we can see we're modifying the login button, performing the login, and succeeding. And we actually got to the end. Fantastic. Self-healing at work. So let's go back to our dashboard. What we can see here now is that our test has this magic wand. assigned to it. And this indicates that there was a self-healing event, one or more in this test. We can also see at the batch level or the test suite, the equivalent of a build that includes all the tests that ran, that there is also this indication. So if you're looking for the runs that had self-healing in them, you can easily filter for those runs and find them in order to fix your code at some point. If we click the magic wand, we can see that we have here information that tells us you try to find a button with the login ID. Here's a suggested locator for the new button. We actually healed it. We couldn't find it with the login ID. Here's a suggested locator that you can use to find it and change your test to use. Okay, so, and the test actually succeeded. If we go ahead and watch the video of that run, we can actually see that the button did change to blah blah, which means that we did change the ID and we did manage to change the text with that ID, and the test still managed to pull through and continue to the end instead of failing. Pretty fantastic. So I've shown you everything that I wanted to show you, and I think it's time to answer any questions that you may have.
This one comes from Peter. Does it support API calls, which is widely used in Cypress tests?
Okay, so right now, the first version of the Execution Cloud supports Selenium tests in all language bindings and WebDriver I/O. We are working currently on Cypress and Playwright support, and we will also have Appium support later in the year. So right now it does not support it, but it will soon support it.
Okay. All right. Here's one from Ryan. Are there cases where this will give false passes in that an element has changed in a way what should be a defect, but is it actually self-healed?
That is a great question. So first of all, the technology is very robust. It will actually find an element and heal it only if it should happen. Of course, nothing is 100%, but it is very, very accurate. I think that at the end of the day, when we're talking about interaction code, you should let the test continue so you can get as much coverage as you can. If there is something that you need to assert, for example, if you are trying to find an element by a certain internal ID and you want to make sure that that ID doesn't change, you should probably assert on that ID and not rely on clicking it by that ID. It would be a best practice to assert on things that you want to validate so you can distinguish assertion failures from just test crashing by not being able to interact with elements. Okay, so there's so many more benefits to helping your test survive than to not doing that in fear of 1 in a million chance that maybe something else will be clicked and you will miss a failure.
Okay. Next one we have is self-healing already included in the current eyes plan?
Yeah, so first of all, the Execution Cloud and Self-Healing are sold separately from eyes and the Ultrafast grid. They have their own pricing, which is independent of eyes. Basically, it is charged by concurrency of the Execution Cloud itself. So it is not covered. If you're running tests on the Execution Cloud, there could be tests that are not running ICE tests, so it's completely independent. Having said that, of course, there are incentives right now for early adopters to try it out and get it with a discount, and also for Applitools users that already use eyes and the Ultrafast grid, they also have nice discounts to start using the Execution Cloud. I have to say that even from the start, as I mentioned in the beginning, the Execution Cloud costs half of what the competition costs. So even the starting point without discounts, it is an extremely affordable offering that can help you save a lot of money on cloud infrastructure.
Okay. All right. So the next one we have is if the validation point is check the label of any button and the label changes later, how will it handle?
So if you have an assertion on the label and the label and the text changes, your test will fail because of that assertion. That's what will happen. Okay. By the way, this is one of the advantages of doing using visual AI for testing, both functionally and visually, because you allow your test to run until the end. You're not wasting lines of code on each of the labels. You're checking full pages at a time. The test ends, you get a report saying, hey, I found some differences. You can very easily see the differences with your own eyes, what's changed. And with the click of a button, you accept those changes if they are correct or reject them if there's a bug. Your test run until the end, you get all that coverage, a single line of code, and everyone in your team, not necessarily a developer that needs to go into the test code and fix the test code, can just maintain the automated test by clicking buttons. Okay, so that's one of the huge advantages that eyes have.
All right. Does self-healing work with complex XPath, which contains keywords, line following ancestor?
Yeah. So basically, all we need is just for you to locate the element. I don't care how complex the locator that you're using. Once you found the element, we gather a huge amount of information on it, and then we have our own algorithms to continue in finding the element. From that moment on, this very complex locator of yours, you can think of it as becoming an Applitools locator. It doesn't matter anymore if it is related to the way that the page is structured or not. Even if the UI changes and no longer your locator is no longer applied, it is just a key to a database where we have all the information about that element, and we have very elaborate strategies to still find it for you, right? So the answer is yes, we support all sorts of locators, all of them basically.
Okay. All right. And what happens to the key in DB when an element is self-healed?
So the key doesn't change. The key is the locator that you are using in this test to find the element. If we find the element, we use that locator as the key. And if we don't find the element, and if we are able to locate the element with your locator, we gather the data and store it in the database and keep it fresh. If your locator cannot find the element, we still use our own techniques to find the element and store all the information about it under that same key. As long as you keep using that old key, we'll be able to find the element for you. If you're using another key, it will be a fresh discovery of the element. And if we find the new element with that new locator, we'll just relearn everything about that new element and store it with the new key. So you don't need to worry about cleanup or anything like that. It just works.
All right. Here's another one. Let me sort these up, folks. How come your execution cloud is faster than the other lab providers?
Okay, so it's a good question. I can only give a partial answer because I really don't know how the other lab providers built their infrastructure. I only know how we built ours. And I also cannot get into too many details about why it's so fast because this is proprietary knowledge of the company. So here's what I have to. This is what I think. First of all, the other lab providers have very mature clouds that have been built a decade ago. Maybe they've been updated, but basically probably based on older technologies. We built a new one based on the most modern computing architectures that are available. We have very, very strong engineers in Applitools. Everyone who's our customer knows how stable and fast and pristine our services are. So we made use of all our great engineers here. We are not sparing any resources on the quality of the hardware that we use to run the test. We're actually using very strong and powerful machines to execute the tests. We have many optimizations that make sure that as soon as you start a test, there is always a browser waiting for you. So you never have to wait for a browser. And basically all these things together add up into saving many seconds out of every test runs, which, that makes the difference, as you saw now in the demo.
Okay. So this was a comment in the chat. We'll take a couple more here. Is it possible to tune the accuracy of self-healing?
Actually, no. There are no thresholds involved. We never trust this approach, because when you allow people that don't really understand to set numbers, they just make mistakes and end up doing the opposite of what they intend. What we want is to do is basically just work perfectly out of the box. And if you encounter cases where it doesn't work, we consider it a bug and we'll improve it for everyone. So you just need to trust us to make it work for you.
Okay. This one's a good one here. In a corporate environment with difficult internet access, is there a version for the situation that works locally?
So no, you cannot install it locally, at least not today. As I mentioned before, you can easily set up a tunnel to test locally. As long as you have an internet connection from where you're running the test to the outside world, we can actually seamlessly test whatever application that is accessible from where you're running your test, from your test machine. And that's how we can get to test internal applications. I'm very proud and excited about this new offering. I know how well it runs because we've been running on it for almost a year now to test internally everything that we do. And I encourage you all to give it a shot and try it out. I'm sure that you won't be disappointed.
Again, thank you so much for joining us, and we look forward to seeing you again soon.